Here we go. We're going to run through this question here with a bunch of different problems with it. We have this f of x equals 3x squared plus 12x minus 4. And the first thing we're going to do is state the vertex. Now, how do we begin the vertex if something is given to us in standard form like this? What's that formula? But what is it that equals? All formulas have an equation, have an equal sign. So what is it that equals negative b over 2a? X equals negative b over 2a, right? So by the time you're done using this formula, you're going to end up finding only the x coordinate of the vertex, which means you're going to have to put that x value back in the function to get the y coordinate. Very good. Okay, so in this case, I have negative b over 2a. That's negative 12. This is my a, this is my b, this is my c. A is 3, b is 12, and c is negative 4. Although I don't need c, do I? So I have negative 12 over 2 times 3. Okay, which is 6. Negative 12 over 6 is what? Negative 2. That is only the x coordinate. It's not the vertex. Okay, a vertex is an xy coordinate point. So you need both an x and a y coordinate. So I need to take that negative 2 now, and I need to put it back through the function to find out where the function sends a negative 2, or what y value is paired with the x value of negative 2. So I need to do f of negative 2. And the function f says 3 times something squared plus 12 times something minus 4. That's something that I need to use is that negative 2. So I'm going to go back, and my input will be a negative 2. A negative 2 here, and a negative 2 here. Do I do negative 6 first, or do I do 4 first? What do I do? I do the exponent first. Okay, so I have to square the negative 2 gives me what? 4. And then this is minus 24 and minus 4 more. So 12 minus 24, minus 4 more? Negative 16. So this is telling me that f of negative 2 is equal to negative 16. Put that information together and give me the vertex.
Negative 2, negative 16.
Negative 2, negative 16. So my vertex is negative 2, negative 16. Done. Now I'm not going to ask you to graph this thing, okay? We didn't have any graphing with this question, so I really don't care how big or small or yucky it is. I'm not going to have to plot it. All right, negative 2, negative 16 is the vertex. Part 2, or next bullet. Write f of x in vertex form. And then underneath there I wrote what vertex form is. Vertex form is f of x equals a times x minus h squared plus k. Which says basically give me any vertical stretches or shrinks and any vertical reflections as well. Give me the horizontal shift and give me the, what's this thing on the end? Vertical shift. Give me the vertical shift. All right, well, I know the vertex. The vertex is negative 2, negative 16. So this quadratic, and I hope you know it's a quadratic, right? The parent function is y equals x squared. So since the parent function is y equals x squared, and my vertex is negative 2, negative 16, it means that the vertex of my parent function has been moved to the left 2 and then down 16. So you should be able to come up with that. If my parent function got moved left 2, then what do I see here? I see an x plus 2. We've done our transformations and shifts left and right already and tested on that information. So that should be an x plus 2. This indicates a shift to the left 2. Now how do I indicate a shift down 16? Minus 16. Now the a value here is always the same a value as it is in standard form. So whatever the vertical stretch, shrink, reflection, whatever it is, whatever's here is going to be the same thing that is here. What am I going to write? 3. This is vertex form.
Oh, that's it?
That's it. Okay. Sometimes the question is not so much all the work that needs to be done to get it done, but the thought process of figuring out what it is you need to do. Calculus is like that a lot. We don't necessarily have to do a lot of grinding in calculus. Sometimes we do, sometimes we don't. But it's the thinking process that's going to get you. Everybody always says, well, if I knew that's all it was, I would have been able to do that. Yeah, we're all able to do it, but are you able to know that that's what you need to do? That really is the thought-provoking question here. Okay, next thing. And I think I'm still good on room on the board, right? State the restricted domain x to be 1 to 1. Anybody have a guess? X is greater than or equal to -2. So I said I wasn't going to graph that thing, right? If I did graph it, isn't it really -2 down 16? Aren't we down here at a vertex? -2, -16. And isn't this graph some kind of a quadratic that opens what? Opens up. This quadratic opens up like this somehow. I don't know the exact graph of it. I don't care. But is that function 1 to 1, the one I just drew? No. No, a 1 to 1 function means every x has one y. That makes it a function. But 1 to 1 means every y has exactly one x. It's a 1 to 1 relationship. And this is not true. If I draw a horizontal line, this graph is going to pass that horizontal line, which represents a y value, more than once. So I want to restrict this domain so that I pass my horizontal line test, so that the function is 1 to 1. And we've talked about this. We can take from the vertex and go left, or we can take from the vertex and go right. So I'm asking you, every single time you do it, let's take the vertex and go to the right. There's one person in here that actually took the vertex and went left. Okay, mathematically it's not wrong, but it's not right. Just kidding. So I don't want to see this part of it. Basically, we are restricting the domain, so we only have half of the parabola from the vertex to the right, and we are making that into our restricted domain to allow the function to now be 1 to 1. Once the function is 1 to 1, I can reflect it over the line of y equals x, and I can have an inverse function. Okay. Good to go in this? Okay, now I want to calculate the inverse. Can you see my marking on the board right there?
I can see it.
Yes?
Yeah.
I mean on the video.
Yeah.
Okay. I'm testing. Just testing. Okay, so we are going to calculate f inverse of x. We're going to do this by using the vertex form because it's faster. Faster and easier. If you've tried to do the process using this quadratic form over here, the standard form, you're going to get stuck. Because you're going to have y squared and y, and it's going to be messy, and you're going to be like, I don't know how to do it. So it's much, you can do it, but it's much easier if you take the vertex form. That's why I had you convert it into vertex form first. All right, so the first function I have, f of x equals 3x plus 2 squared minus 16. Step 1. Oh, God. Step 1. Don't need to change x and y. I don't have y yet. Step 1. Put y in place of f of x. Replace f of x with y. That's your first step. So I have y equals 3x plus 2 squared minus 16. Now we interchange the x and y. So I have x equals 3, open parentheses, y plus 2 squared minus 16. And now I only have a singleton y and a singleton x, which is going to make life easy. If I have a singleton y, I can be able to solve for it a lot easier. Okay. Now I need to undo this package. Remember the sock shoe example? And I got to undo everything that's being done. What do you think the first thing I have to do to this side of the equation is going to be to unwrap that y? Add 16. Add 16. Okay? No, I'll help you. Just listen to me clearly, okay? Ready? If I were to put something in this function right here, what would be the first thing you'd do with it? Add 2. And then you would what? This is for you. You would add 2, and then you would what? If I told you to find f of 7, if I told you to find f of negative, oh, no, forget that. If I told you to find f of 7, what would be the first thing you'd do with a 7? Say it. Subtract 2? If I said find f of 7, and you would put a 7 in, right? What would be the first thing you would do? Add 2. Next thing.
Then you would square it.
Square it. Next thing.
Multiply by 3.
Next thing.
And then subtract by 16.
What's the last thing you said?
Subtract by 16.
Undo that.
Now you add it by 16.
Done.
Good job.
Okay, we are unwrapping that y. That's a present. This y, in this case, is over here. we're unwrapping this y. This y is embedded in this present, in this present, in this present, in this present. It's like putting a box inside a box inside a box, and wrapping and wrapping and wrapping and wrapping. You gotta unwrap the outer box first. Add 16, this gives me x plus 16. If you were playing with me, shame on you, because we don't have time for that, right? Okay, shame on you more. Okay, next thing I need to do, divide by 3. I'm gonna turn this around, right? Y plus 2 quantity squared equals x plus 16 over 3. I don't really care how nasty it gets. Square root both sides. So y plus 2 equals, now when you square root both sides of an equation, you are supposed to introduce a plus or minus sign, okay? So it ends up going away because we have restricted our domain. We'll talk about that in a minute. This is really plus or minus square root of x plus 16 divided by 3. Is everybody lost?
No.
Good.
Wait, I'm lost. I don't understand why we have a square root over x plus 16. On my inside.
You do?
Yeah.
Okay. I didn't write it in here, but you're square rooting this side of the equation to undo the square. And you're square rooting this side of the equation because what you do to one side of a balanced equation, you must do identically to the other side. Okay. So this undoes my square, and I just get y plus 2. What's the last thing I have to do to get y by itself? Subtract 2. So this is going to give me y equals negative 2. Now I'm going to play this concept here about this plus and minus. Remember, my restricted domain is x is greater than or equal to negative 2. I'm going to write that here. Do I have room? I hope. X is greater than or equal to negative 2. Is that on the picture? Okay. So x is still greater than or equal to negative 2. Didn't I just interchange x and y's? So what does this mean?
Wow.
It means y has to be greater than or equal to negative 2. Which all the way down through here, it means that the y has got to be greater than or equal to negative 2. Did I do something wrong?
That's the range. That's the range.
Yeah, of this particular thing, you'll see. So we got the, yes, the domain of the original f of x function becomes the range of the inverse function. Perfect, nice comment. So if this says plus or minus the square root of x plus 16 over 3, isn't it, I hope it's true, I hope you get this, isn't it true that if I do negative 2 minus, that I'm going less than negative 2? But I'm supposed to be getting greater than negative 2. Greater than or equal to. My y value has to be greater than or equal to negative 2. So this negative sign can exist because of the restricted range of my inverse function, which is a result of the restricted domain of the inverse function, of the, sorry, not inverse function, of the original function to make that function 1-to-1. Last step in here is to replace the y with what? We say f inverse of x equals negative 2, and now I'm going to choose the plus sign and not write the minus on purpose because of what was written here. And I'm just going to leave this nastiness right here, x plus 16 divided by 3. I'm not going to worry about rationalizing any denominators or anything. I'm going to say that that is the inverse function. I'm going to come back over here and I'm going to erase the very first part of this in order to put the last bullet. I think the last bullet's probably the easiest part of the whole thing. I'm sorry. The last bullet says complete. And this time I've switched my columns. Anybody notice that? Columns and rows. I switched them up. This says domain here. And range. So you have to pay attention. Last time it was f of x and f inverse of x, and domain and range were here. So one thing you know quickly, what is it? You know the domain of f of x because you found it. It is x is greater than or equal to negative 2, which means you know the range of the inverse. Y is greater than or equal to negative 2. We found our vertex. What was our vertex? Negative 2, negative 16. Kind of need that, and I know I erased that picture, but remember it was down here, and we decided to take it up. We need that vertex to look at the range. What's the range of my my original function. Y is greater than or equal to negative 16. The range of the original function is y is greater than or equal to negative 16. Therefore, you know the domain. What is it?
X is greater than
Good job. And that wraps it up. Now, I didn't have you graph it, but I'm just going to ask you, if negative 2, 16 is a point on the original function, give me the point where I'm going to start on the inverse function. Negative 16, negative 2. Just interchange the x and y. So negative 16, negative 2 would be over here someplace. You continue plotting points all the way up. You continue plotting points all the way over. This would be your inverse function. Dotted line y equals x. Doesn't it look cute? You see the mirror image? It's just a little extra to pull it to the end. Okay? All right. Can you push stop on there? Talent out.